Okay, thank you for that great introduction. Before I get started, what is the latest development that you guys have heard this week in the field of what many people believe is AGI? Any hands? I heard something there, but I couldn't make out what was. But maybe I'll give a hint. Mr. Elon Musk, besides running Doge, is also trying to send people to Mars using Grok 3, the latest release of a software that claims to be AGI. What I'll look to do over the next about 7 minutes is deep dive into what exactly is happening in the background, where we are seeing changes and improvements as we go along. First and foremost, everybody is familiar with what we see on the screen here. Different use cases where AI has been used already for a number of years. Very, very narrow applications. Pick up a specific use case, build an AI that does exactly that. Over the last 2 years, things have changed. There is a lot of creative use cases in the block, including, as I said, sending people to Mars. But is that really AGI? Do we understand what AGI means? AGI, if I try to put it very simply, is machines learning continuously to do a wide range of tasks, actions that span a number of use cases. So essentially, there are two key things that are very important for AGI systems to work. First, it needs to be general purpose. Second, it needs to be flexible to move from one task to another. And why are those two important? Those two are important because what we are talking about is human-like intelligence. It should be able to replicate and do as well as a human across a wide range of things that are happening. But why are we talking about it now? Why is it important today to think about it? I already mentioned Grok. There are a number of releases. Last 6 months alone, every few weeks there is something new that is coming out. Everything new that claims to do a lot and take humanity where we've not gone before. So what I'll look to do is understand, I'll pick up an example of DeepSeek and try to understand what exactly is changing under the hood. And this might be the only technical slide that I have here. What you see on your left essentially is the transformer architecture, the one that Google made famous with their paper and ChatGPT kind of brought to all of us. There are two key places in which a system like DeepSeek is changing how the algorithms are working under the hood. I'll unpack these in the next couple of slides. First, typical GPT models essentially work with tasks with a very densely packed architecture. It is like picking up a generalist, somebody who knows a bit of everything, and trying to solve problems using that. What DeepSeek, and just a little before that, GPT-4 also tried to do, is move to multiple smaller models. Each of those experts. Think of it almost like when you go to school, when you go to college, you go to a hospital, you approach the building, but then you go to where you want your work to get done. You might want to go to somebody who's a specialist in oncology, somebody who might be a specialist in skin diseases and things around that. So these are smaller experts that are trained at a very different level and then brought together by somebody who's controlling the strings there to ensure that whatever problem you're trying to solve for gets addressed, which is known as the mixture of experts, essentially making the whole training process much faster and bringing down the cost like we've been talking about. What it also leads to downstream is much faster inferences on any decisions that you're looking to make. So that's the first level of change that is happening, called mixture of experts. Second, and I'll pick an example again here, a very typical user prompt when you're interacting with a chat system or any sort of interactive system. I ordered something, I was expecting it on a certain day, it did not come. That's the question that I'm asking the system. In typical GPT models, every single word carries a token, and as you move forward, each token gets carried forward, so that by the end, the computational power needed to answer something like this is very, very heavy. It's a very simple tweak that was done by DeepSeek. that took them time to do. But essentially, they are working off what we call as key concepts, or in old-fashioned way, topic modeling. They are modifying a part of that, picking up only the key concepts from what is given to it as an input, working on something that is known as latent vectorization, where at each stage, vectors are being created and stored, but they are not used all the time. Depending on what you're trying to drive for, those vectors get picked up. Essentially, again, meaning faster inferences, more scalability in how that is happening, and ensuring lower memory usage. Unfortunately, in public literature, what you always read about is just the memory part, how they are doing things in 8 bits, which needed 32 bits earlier. But these two changes at a software level or at an algorithm level is what is driving that behavior. Now, this has implications. It has implications because now suddenly you can have many more applications running on your mobile phone or other smaller devices which do not have that heavy intensity of processing power available. So it's opened up a plethora of use cases for generative AI to actually start addressing. But that's all very technical. How do we make it relevant to each of us? I've put together a quick example, a comparison between DeepSeek and GPT and where things are today. First level, we already discussed architecturally, mixture of experts versus a dense model, efficiency and specialization versus versatility and scale, and input variables also differ. That's an architecture level. Second thing that we are all noticing is how the reasoning power of these models have changed. DeepSeek, for example, uses a reinforcement learning-based way of doing reasoning, whereas GPT is more a multi-step problem solving. Now, those sound very similar, but how they play out is where it is different. Where should each of us look to use these softwares if we want to? First, DeepSeek is excellent at technical problem solving. It gives you step-by-step reasoning on why it is recommending certain things and how you should think about it. Whereas GPT is excellent for creative tasks. And third, which we don't see here, is if you want to go to Mars, it is still Grok 3 that you want to go to. Now, why is this important? Why is this important to the topic that we were talking about? The reason is, as we see, each model is focusing on very specific attributes that it is trying to address. It is, in a way, still very, very narrow. And therefore, the submission that I leave all of you with is, while we are going closer to what is AGI, we are still some ways off. Thank you so much for your time.